Okay, so what we're going to be doing is 2.6, number 1 from Ready, Set, Go. And it's asking you to, it says use first and second differences to figure out if the pattern is linear, if the pattern is quadratic, or if it's neither. And then if the pattern's linear, then write the explicit and recursive. If it's quadratic, just write the recursive. And then if the pattern is neither, then identify it and then just stop. Okay. So here, the very first thing that I'm going to do is I'm going to do what they call as first and second differences. What they're asking you to do is subtract. They say bottom minus top. How did you get here? Right. So -17 minus -23 is +6. So here, I'm going to check if that's true again. -11 minus -17. Oh, look, it's +6. And again, -5 minus -11 is again +6. Again, 1 minus -5 is again +6. Because these are all 6, this actually is really important because these are all the same, this means it's linear. Linear because same. Okay. Linear because they're the same. If this row here, the first, they call it first differences because I just subtract one set of differences, right? If I had to, if these were all different, like it said 2, 4, 6, 8, 10, these are not the same. So then I would subtract those differences and to see if those numbers would be the same. But because all of these are the same, this tells me that it's linear. And it's linear because this guy actually turns out to be my slope. Or my constant rate of change. How does that help me, Ms. Johnson? Well, because they told you that they want you to find the explicit and recursive if it's linear, this guy shows up over and over and over again in both of those. So, okay, let's go down here. So identify the pattern as linear, quadratic, or neither. So he's linear. If the pattern is linear, what's the explicit equation? So because it's linear, I know that the base form is y equal mx plus b, meaning every single linear equation could be written of the form y equals mx plus b. Well, what's my m and what's my b? M is my slope, right? So that guy shows up right here. So you want me to put a 6 there, Miss Johnson? Exactly. So I'm going to put a 6 there. Miss Johnson, what's my b? Well, b is my y-intercept. It's when x equals 0. Okay, and this is going to show up one day. So then this is my y-intercept, and it's when x is equal to 0. So when x is equal to 0, or in this case, n, you want me to grab my -5? Yes. So you want me to put -5 in for b? Yes. So and then I highlight this guy and say, hey, you helped me. This is my y-intercept. It's as a point. You guys all see it? 0, -5, where -5 is my b. Okay, so you want me to put -5 instead of b? Yes. Done. Okay, and then I just pull down the y and the x. Exactly. There's your explicit equation. Ms. Johnson, why do they call it an explicit equation? So the word explicit just means like it stands on its own. Like if I tell you something explicitly, I don't need to like say, oh, I need to check with so-and-so about what he thinks about, you know, what homework we should have. Explicitly, I'm telling you, you need to finish this homework. Does that make sense? Explicitly also means that it's like it stands on its own. You don't need anything else. Versus recursive doesn't stand on its own. Recursive is almost like, think about like our blue and gold days, right? I know that today was a blue day because yesterday was a blue day, a gold day. I said that wrong. Let's try again. I know that today was a blue day because yesterday was a gold day or yellow day, whatever. Okay. And because today I know is a blue day, then that means tomorrow is a yellow day, right? So the only way that I know what today is, yellow or blue, is based on what was previous to it. And that's what recursive means, right? So if you asked me how old my sister is, I don't know her age. I only know her age recursively according to mine. She's 6 years older than me. So then I take my age, oh yeah, and then I add 6 to it. That's a recursive equation. I don't know her age explicitly. I only know her age based on my age, which is recursively. Does that make sense? Okay, so the recursive equation looks like this. F of 1 is whatever, and f of n is equal to f of n minus 1 something. So if I asked you, recursive, people get really confused because it looks so complicated, but it's like one of those things that looks really complicated, but in fact, if you kind of like peer into it, it actually makes a lot of sense. So if I asked you like, hey, can you describe this pattern? Let me just ask you, hey, in the chat, can you describe this pattern? What would you say? What would you say? Uh-oh, did I lose you? What would you say if I said, hey, can you describe this pattern? What would you tell me? Yeah, you add 6 to it. Ms. Johnson, it's going up by 6. So that's recursive in words. So you would say something like up by 6 or add 6, something like that, right? So yeah, I would do something like that. So so you would add 6 to what? What would you add 6 to? And then someone's like, well, you'd add 6 to the previous term. Oh, okay. So this guy right here, his name. So like in languages, right? How do you say bathroom in Spanish? You'd say baño. How do you say previous term in Spanish? I mean, in Spanish, in math, it's f of n minus 1. I know it looks really weird, but it's a lot shorter to write than writing the word previous. So mathematicians are very good at coming up with really efficient ways of writing things, right? So f of n minus 1, okay? So then who would you add 6 to? Oh, the previous guy? Oh, so you just want me to put add 6 right here? Yeah. That's it. So the only other part about my previous term is I need to know the starting point. So here's my starting point, f of 1. And I just chose 1 because that's the number that people usually use. If you wanted to do 0, great, do that. But I did f of 1, so then you pick 1. Oh, f of 1 is 1. So then you just put 1 here, 1. F of 1 is 1. Because why? 1, 1. So you can't tell me to add 6 to something previous if you didn't give me a previous to start with. So that's why we need both of these parts. So if I said, hey, I'm going to double your money every single day, you're like, sweet. But you never told me how much money you had in the first place, then I don't have to double your money. Does that make sense? So if you never told me how much money we're starting with, then I never have to give you double the money. Does that make sense? All right.